In this I do problem, we've got some aluminum metal that's reacting with air and forming a thin coating of aluminum oxide around the outside. So if we're going to picture this, let's say here's my sample of aluminum. So we'll assume this is all aluminum on the inside. On the outside, we're forming a coating of aluminum oxide, Al2O3. As it reacts with oxygen in the air. So kind of keep in mind, it might help to draw a picture here. The mass of this whole thing, they are saying, let's see, is 120.91 grams. And out of all of the sample, we've got 120.32 grams of that is just aluminum only. Okay, and that's aluminum originally inside the bar plus any aluminum that's in the coating part. So kind of keep that in mind. So we're going to write a balanced equation first. So A just says write the balanced equation. So let's see, we would have 4 moles of aluminum react with 3 moles of oxygen gas, and we would expect to produce 2 moles of Al2O3. Now, the first part says what mass of oxygen was in the sample. So for part B, we just have to do a simple subtraction. If our total mass was 120.91 grams, and that's for the mix, and we just subtract the aluminum, because the only thing in this mixture is aluminum and oxygen. So we'll subtract 120.32 grams, and that's just aluminum. What we have left over is 0.59 grams of O2. Okay, so A is done, B is done. So let's see, C, what mass of aluminum oxide was in the mixture? So we're going to do a little stoichiometry, I think, for this part using the balanced equation. Let's go ahead and start with our 0.59 grams of oxygen, because we know if we have 0.59 grams of oxygen, we can figure out what mass of aluminum oxide by using dimensional analysis. So let's start with 0.59 grams of oxygen. And the very first thing we're going to do is convert to moles. So when in doubt, convert to moles. And we know that 1 mole of oxygen has a mass of approximately 32.0 grams of oxygen. And that way grams cancel. And now we want to go to aluminum oxide. So we're going to use our mole ratio. And we can see from the balanced equation, our mole ratio here is 3 to 2. So for every 2 moles of Al2O3, we use up 3 moles of oxygen. And that's the part of stoichiometry you have to have every single time, is that mole ratio. And then from there, we can actually figure out what the mass is. And 1 mole of aluminum oxide, Al2O3, according to our periodic table, has a mass of 101.948 grams of Al2O3. So that means when this reaction is finished, the coating is going to basically be 1.3 grams of Al2O3. All right. And then for part D, what is the mass percent of aluminum oxide in the mixture? So in other words, we want to know what the mass percent is of just the compound aluminum oxide out of the whole mixture. So a mass percent is just taking the grams of the aluminum oxide, because we're looking for the mass percent of aluminum oxide, divided by the mass of the whole compound, or the whole mixture, I should say, which is 120.91 grams. So it's just like finding a regular percent composition. What percent of the 120.91 grams is aluminum oxide? And then to officially make it a percent, we multiply by 100. And that gives us about 1.1%, which hopefully makes sense because it's just a thin coating. All right. Oh, there we go. That's it.